Okay, so what is the index notation? So basically we have the numbers like this 6 times 6 equals to 6 squared, right? So we realize as 6 squared or the 6, so we can write as 6 squared. We can write that 6 squared, or we can write that as 6 to the power of 2, right? So we can use we can say 6 squared or can 6 to the power of 2. Okay, let's look at the next one. How about this one? 6 times 6 times 6. So we can write this. Okay, so what is this? It's a 6 cubed. Okay, 6 cubed. So we also can write as 6 to the power of 3, right? Okay, so the next one we also can write this. Okay, so we also can, for example, we have this 4 6 times each other. So how can we call this one? We call it 6 to the power of 4, right? Okay, and so on. So we can write all those things. So in this case, so this notation, okay, this notation, we give the name. We call that as an index notation. Index notation. We call it index notations. Okay, in this notation, the number at the level is called base. The number on the top right hand side corner is called index. So what's the meaning? Okay, let's write this one. 6 to the power of 4, right? Okay, so basically 6 is the base. We call that base. Okay, so on the top right hand side, the 4, this 4, we call that what? We call that is the index. Index, we call it index. So the whole notation, so we call that is 6 to the power of 4. Okay, so this is the thing. Okay, so basically we will use this thing to represent this index notation. So it's a 6 to the power of 4. Okay, so basically, so why we talk about this? So we can use these index notations to represent the prime factorization of the number. So we can use this index notation to represent. We can represent what? We can represent the prime factorization of a number. Okay, so we can do that, right? We can do that, right? Okay, let's give an example. Okay. So find the prime factorization of the 792 expressing the answers in index. So find the prime factorization of, so which number? Of 792. Okay, this number, and express the answer in the index notation. Okay, let's see how to find out this number. Okay, so basically we can use the factor tree. Okay, let's use the two methods. We have two methods, right? We'll discuss that one. So let's talk about the first one. Okay, let's talk about the first one. First one is the factor tree, right? So 792. So we can divide by this. Which number? So can we put that number A here? So A is how much? So it's 7, right? That's right. Yes. A. The first one is 9, right? 9, right? Now we get 72, 9 minus 2 is 772, so 99, okay, right? So we get 99, so here, how about A? The A we can divide by the 2 and 4, right? And then how about this 99? 99 we can divide by 9 and 11, so everyone knows about that. So can we continue to find the factory tree for this 4? Yes, 4 can 2, right? How about 9? 9 we had 3, right? Okay, so what's the answer? The answer is 792 equals to 2 times 2 times 2, 1, 2, 3, right? Then times another 2, 3, and times 11, right? So this is the basically this is the prime factorization of this 792, right? So can we use index? Can we use the index notation to represent this? Right? Just now we have learned, right? The index notation, right? Okay, in that form. So the base, we have the base, we have the index, right? So here, can we put that these two? So we can write this, right? So in this case, this is a 3, this is a 2 cube, right? Then how about this 2? So this 2 is what? This is the 3 square, right? Then we also times 11, of course 11, so 11 only have 1, right? Okay, so basically, okay, from here we use the first method, we call that is the use the factor tree, okay? We use the factor tree. Let's look at it. Let's look at the other one. Let's look at the other one. Okay, last class we also see the alternative method. Alternative method is basically we call that it's a successive short, right? We can use the successive short derivations, right? Successive short derivation, right? Okay, so how we going to do that? Okay, so first, okay, we have this 792, right? Okay, can we divide by 2? Yes, right, we can divide by 2, right? So what we get? So here we put a 3, right? 3 is 19, 19, so can we put a 9 here? 9, 1, we put 6, right? How about 2? Can we put a 1 here? 1, so 19, can we put a 9? So 1, 16, can we put an 8 here? Right? Then we continue. Can we put another 2? Just try, okay, can we put the 9? So 18, 18, yeah, 9. Okay, so that's good. Okay, let's continue. Can we put a 3 here? So we get 3, 3, right? Okay, let's continue. Okay, so can we put another 3 here? Yes, of course, we can put 11. So afterwards, can we put 11? So we got a 1, right? Okay, very good. Now we find the answer. So prime factorization of this number 792. So we got 792 equals to which one? I mean, we have 2 times 2 times 2 times 3 times 3. How much times 11? So that is the thing, right? Okay, and then what's the answer? Okay, we can use the same concept right here. So how many 2 we have? We have 3 2's, right? So it's 2. Okay, then we times what? We times another 2, 3, right? So what's the things? 3, 2, right? Then we also times the 11. Right, we're going to have 1 11 here. So in this case we find the answer, right? Okay, that is very clear, right? 3 for 1, right? Okay, now next look at another example. Let's look at another example. Alright, the next example is the final is a 702, right? Okay, so let's use the first method. So basically same thing, we just divide it into 2 methods. Okay, we just divide it into 2 methods. The first method with the factor 3. So what's the method? So 702. Okay, how we divide this one? So remember, so this of 3 factors we add up together is divisible by 3, then we definitely can be divided by 3, right? So in this case we put a 3 here. So how much we get? We get the first one is 2, another second one is what? 3, then 6, right? Is that correct? Is that the correct answer? So we get this correct answer, right? So okay, let's try this one. 2, 3, 6, 3. So basically, it's no, sorry, it should be 4, right? It should be 4, right? Just to test it, just a 2, 3, 4 times 3, so it's 2, 1, it becomes 0, then 1, 6, 7. Okay, correct. Very good. So let's continue. So how about this number? Can we divide by 2? Let's try 2. Okay, 2, this is 1, this is 1, and 7, right? This is what we get, right? Okay, so how about 7? So can we divide by another 3? 117 divided by 3, so it's 3, 9, it's 29, so we get 9, right? So in this case, it's 3. We have a 3, 9, 2, 9. Okay, so how about here? Can we continue? 3 and 13, right? Is that correct? So now we're able to continue break down this one, right? Okay, so in this case, what's the answer? What's the answer? The answer is 702 equals to what? We have 1, 2, we have how many? 3 times 3 times 3 times 13, right? Okay, that's what we get. We got 3 3's, right? So what's the answer? The answer is 2 times right? Then times 13, right? Okay, this is the answer. Okay, let's try the other alternative way. The alternative way we call that is successive short division, right? So basically, this one is how we use that one. 702. Okay, let's divide by 2. Okay, what we get? What we get? But 3, 5, 1, right? This is the things we get, right? So okay, let's try another one. How about 3? So the first one we get is 1, right? Second one is 1, of course, apparently. Then next one, 7, right? Okay, so let's try about 7, and we try 3. So what's this? So it's 9, right? 10, 27, 10 is 9. Okay, let's try another 3, right? So we get 13, right? Let's continue 13. We cannot break down because 13 is already a prime number. So in this case, we will put 13 and we get 1, right? So here we got answer. So in this case, we got answer already. So it's a 702 equals to 2 times 3 times 3 times 3 times 13, right? So it's very clear, right? So in this case, what's the answer? 344, right? We put these 3 together. So we got 3, right? Then we times 13, right? Okay, it's very straightforward, these 2 questions, right? Okay, let's do a summary here. So basically, we have this. So if we have this index notation, so basically index notation. Okay, so what we have, so effectively we have this 6 times 6 times 6 times 6, so equal to 6 to the power of 4, okay? 6 to the power of 4, right? So, okay, how we call this number? So how we call this? So we call this 6 is the base, okay, 6 is the base. What's about 4? 4 is the index. Okay, so the whole thing that we call the index notation. Okay, so no index notation. So in this case, okay, why we will find out this? Because okay, when we do this, when we do the factor, prime factor. When we do the prime factorization, so we can use this index notation to express it, right? So okay, that is a very good point for this index notation because it can represent the prime factors of a number. Okay, so we can use that one. We already demonstrated in 2 examples. Alright, this is the index notation.